So in this lesson, we are going to talk about parabolas. In the last few lessons, we talked about completing the square and equations of circles. This is our last conic section we're going to deal with this year, and it's one of the most important ones. It's called parabolas, right? And so we've talked about quadratics in general before when it came to factoring, finding zeros, all that. So you should hopefully recognize this form of the equation. And this is the standard form of a quadratic. Like I said, this should look familiar, right? Because whenever you have that x squared here, that is going to be one where you can factor it. It's going to be an equation that looks something like this. Okay, so that's a parabola, that's a quadratic. We've seen these types of equations before where we have that x squared. We might not have dealt with this much, but vertex form is just another form of the equation for a quadratic where you can actually see the vertex. And we've dealt with this actually when we're talking about circles, right? You can see that vertex right there, that HK is that vertex. And the graph for quadratics are always going to be called parabolas. So that word parabola is basically just the shape, the graph of that quadratic. So that should be a bit of review. Maybe we haven't talked about a lot of this year, but hopefully you guys recognize this form of the equation here for the quadratic. Now we're going to go a little further to, again, graph these parabolas and write their equations for today. Okay, so what we've done before is we know parabolas can open up or they can open down, so we've seen graphs that look like these kind of U shapes, right? What's new is we are now going to look at a graph that can open left and right. So what that typically means then is when it's opening left and right, that the y is going to be squared. And we're going to see that in a second when we look at the actual equation. Another thing that's new is we used to always solve for y, and we were doing that a lot when we were completing the square and all that. But now we can actually solve for x squared or y squared. And this is going to feel a little bit different because, like I said, we are typically used to solving for x or solving for y, but in this one we are going to be solving for x squared and y squared. Like I said, we'll see some examples of that in just a minute. All right, so now let's go ahead and label this parabola. So the first thing we're going to label is the vertex. Hopefully that should be the easiest thing to label on here. The vertex on this specific graph is going to be the lowest point. In a parabola in general, it's just kind of either depending on which way the parabola opens, the lowest point or the highest point in the graph, or the leftmost or rightmost point, just again depending on where it opens. So in this one is that lowest point in the graph, that's our vertex. The next thing we're going to label is the axis of symmetry. So that is going to be going right through the vertex. It's going to split that in half. I think of an axis of symmetry kind of like, think of like a butterfly, right? You can fold it in half at that point and it should line up perfectly. So that is our axis of symmetry right there. The next thing I'm going to label is going to be the focus. So this is going to be something that's a little new to us. The focus is going to be this point on the graph right here. And what's cool about the focus is anytime you have a point that goes straight down towards the parabola, it would bounce right off that and it's going to hit that focus every single time. So again, if I have this point that just kind of drops right down here, it's going to bounce off and it's going to hit that focus every time. So that focus is an important thing. I think about a satellite dish when I think of a parabola, right? You probably haven't seen these a lot recently, but a satellite dish, right? A lot of people used to put them on the top of their roof to get like extra signals for channels. It would come down, like the signal would come down and it would bounce to that focus. Every time it goes right down, it's going to always Always, 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 doesn't matter where it comes down, always going to go right back to that focus. Okay, so that's a focus. What's important also is this distance right here between the focus and the vertex. I'm going to label that P. All right, we're going to come to that when we look at the equation. There's one other thing I'm going to look at, and that's the directrix. So this directrix is a line that goes perpendicular to the axis of symmetry, and it's always going to be kind of outside, I think of outside that parabola, right? The focus lies inside. Think about it as that, like that central point, that focus of the parabola. The directrix is outside. It's like kind of behind it, I think about. And so what's cool about this is that this distance here is also going to be P. Again, my drawing is not completely to scale, but that distance is also P. Something else cool is if I pick a random point, let's just say this random point right here, right? And I get this distance here and this distance here. Again, this drawing is not completely to scale, but these two distances should be exactly the same. The distance from that random point to the focus and that random point to the directrix should always be exactly the same. Okay, so if this is 3, this would also be 3, right? Okay, so make sure you have all that labeled because that's going to become very important when we're graphing and when we're writing the equation for the parabolas. All right, moving on. All right, so transformational form is the one we're going to be using most often for this unit. This first equation is when our x is squared, it's going to open up or down. And so again, like I said, what's important about this one is that our x is squared, okay? That's the one we're used to seeing is when our x is squared. If I look back up to our standard form of the equation, again, x is squared there. This is kind of quote unquote the normal one, right? Where x is going to be squared. Okay, again, that's going to open up or down depending on if this guy right here, that 4p is positive or negative, okay? And then that other important feature of this equation is that h comma k. It's very similar, right, to that circle equation that we've already seen before. The hk here, instead of being the center though, is just the vertex now. So we're using kind of that same logic that we used in creating that circle equation. Now we're going to use that for parabola. So hk is going to be the vertex. Now let's look at our equation that opens left or right. So go ahead and take note of this equation. We got y minus k squared equals 4p times x minus h, right? So very similar equation, except for now what you'll see is that the y is being squared, which means it's either going to open to the right or it's going to open up to the left, okay? And how we tell if it opens up to the right or left is by looking at this 4p, right? If this 4p is positive, it's going to open up to the right. If it's negative, then that's when it's going to open to the left. The next thing I want to look at in that equation is my h comma k. And what you'll see here, the h is always, always, always connected with the x, okay? So kind of flip positions because now the x is here. The k is always going to be with the y. So my vertex is still h comma k. You just got to be careful where that position is that you're writing the coordinate correctly, right? Your x always goes first, your y always goes second. Okay, so now that we looked at these equations, let's move on to kind of defining our p. We already looked at what p was in the graph. It's that distance between the vertex and the focus, and that distance between the vertex and the directrix. So we're going to go ahead and write that down right now. Okay, so what is the distance between the focus and the directrix? So let's draw just a quick sketch here to see. So we have our parabola here, we have our focus right here, somewhere in the middle of that, and that directrix, kind of what I mentioned, it's like behind the parabola. And so, well, I know the distance between the focus and the vertex is p, and then I also know that the distance between the vertex and the directrix is also p. So obviously, what's the entire distance right here? That's just going to be 2p between that focus and the directrix. Okay, so I know that was a lot on the definitions, the pictures, all that. We're going to move on to some examples on how to draw and write equations for these parabolas right now. Okay, so when you are drawing a graph, I listed some of these important features right here, kind of to help you label those on the graph, and it's really going to help you draw the graph as well. So we're going to do those one step at a time. I also rewrote the equation. I would do this for you right here as well. I rewrote the equation we're going to be using. So with this one, what we'll notice is that x is squared, right? Which means I'm going to be using that transformational form that x minus h squared equals 4p y minus k. So kind of already I know it's going to be opening up and down, but I'm getting a little ahead of myself. Let's go ahead and identify some of these important features right now. All right, so the first important feature we have here is going to be the coordinate of the vertex. So that's going to be the hk. Remember, it's always going to be opposite of what you see in the equation. So if I see positive 2, negative 1, it's always the opposite. So my vertex here is going to be negative 2, positive 1. Basically the same as we did when we were doing the equations for circles. Always the opposite of what you see. So I can go ahead and label that on my graph, negative 2, 1. Which is going to be right here. So now let's look at the direction it opens. So it's going to be opening because it's that x squared. I know it's going to be opening up or down, right, because the x is squared. The second thing I want to look at is this value for that 4p. Is it positive or negative? Well, it's positive, so I know that this graph is going to be opening up. Again, the x is squared, which means it opens up or down, kind of like that normal type of parabola. And I know it opens up because it's positive there. Here's how I kind of think about this. Positive opens up, negative is going to open down. Okay. The axis of symmetry, I know is going to go straight through that vertex. So the axis of symmetry, I can go ahead and label right here. Going straight through that vertex. That's going to be the line x equals 2. That's our axis of symmetry. Now we're going to look at the coordinate of the focus. Well, before I figure out the coordinate of the focus, I need to first figure out the value of p. So that's what I'm going to do right now. Well, looking at the general form of the equation, right, we know that our 4p here is going to be equal to that 8. So if I'm just trying to figure out the value of p, it's pretty simple. All I'm going to do, I'm just going to do this to the bottom here. I'm going to set 4p equal to 8. I'm going to solve for p. I know p is equal to 2. Just divide both sides by 4, basically. Okay, so I know p is equal to 2. That's important because that p value is that distance between the vertex and the directrix and the distance between the vertex and the focus. So if I know p is 2, I'm going to zoom into my graph here. Going from my vertex here, I'm going to go up 2 because I know the graph opens up. That is my focus. So I can label my focus as that point, which is negative 2, comma 3. Well, what's nice is that p-value is also going to give us the directrix. So kind of zooming into our graph again, from the vertex, right, that same point here, that vertex, I'm now going to draw in the directrix. And the directrix is going to be, again, 2 units away, just kind of behind the graph now, from the vertex. So right here, and then I'm just going to draw a line straight through it. That right there is my directrix. And that's an equation, right? It's a line, so I need to write an equation for that. It goes through negative 1, so it's going to be y equals negative 1 for that one. All right, so I have my vertex, I have my focus, I have my directrix. Now, like the big part of this, right, we actually have to draw that parabola in. And so I'm going to do that right now. But before I do that, I'm going to give you a quick definition here. So this definition here that says the focal width is the width of the parabola at the focus, right? And that width is 4p. So that's going to give us a nice piece of information so that we can actually draw this parabola in. And what I mean by this, kind of drawing a picture here. Let's say that's my parabola. Let's say this is my focus here, right? I know that this distance here is P from the focus to the vertex. Well, if I'm talking about the width at the focus, right, that width here, that's going to be 4P. That's what I'm talking about. So if I'm drawing that in on my graph, let's go ahead and actually draw this in here. The width is going to be 4P. Well, I know P is 2, right? So I know that this entire width right here has to be 8, okay? Because it's 4 times P, well, it's 8. And it kind of gives us that also in the actual equation itself, right? That 8 right here, that's what the width is at the focus. So let's go ahead and draw this in our graph. So since I know that distance is 8 total, right, I want to draw 4 kind of on each side. So I'm going to go 1, 2, 3, 4, put a dot right there. 1, 2, 3, 4. It's off the graph, but put a dot right there. That is going to give me my final graph. And again, I know there's a lot going on here. There's a lot we have to remember. That's why you need to be practicing this, okay? And use these notes to help you out. Kind of refer back to them, okay, how do I know what the vertex is? How do I know where the axis of symmetry is? Look back at these examples to help you out. All right, so let's move on to another one. This one's going to be a little different because now our y is squared. So there's different features that we're going to have to look at. So let me first rewrite that formula for the general transformational form when y is squared. All right, taking a look at this one. Again, I just rewrote that formula. So the first thing we always want to do is find the coordinate of the vertex. Be very careful. Right now this is switched. So the y is first, the x is second. But again, that vertex is always h comma k. So looking at this one, our vertex here would come from h comma k. So this would be positive 4 because it's always the opposite. Negative 1, that is the coordinate for our vertex. Let's go ahead and draw that in our graph. 4, negative 1, it's going to be right here. Okay, so we have our vertex in, that's our first step. Now we want to figure out the direction it opens. So right away, I see that y is squared. That means it's going to open up either left or right. The second thing I want to look at is what's going on here with this 4p, right? It's negative. If it's negative, that means it's opening up to the left. Okay, so we have our vertex. I know it's opening up to the left. Now I can kind of draw my axis of symmetry. Because I know it's opening up to the left, the axis of symmetry is going to go right through that point. Kind of split that graph in half. Because again, I know it's going to be opening up this way when I actually draw it out. All right, so let's figure out that equation for that graph. That equation is going to just be y equals negative 1. And now let's figure out the coordinate for the focus and the directrix. But before I do that, remember, we need to figure out the value of p first. Take a second. I want you to try to pause this video. Try to figure out the value of p on your own. All right, so hopefully you took a second to pause this video. This value of p, not pretty, right? It's negative 1.5, but we can still work with it. And so since I know it's opening to the left, let's go ahead and graph these points. Starting at the vertex, I'm going to go 1.5 units. This right here is going to be my focus. So that coordinate is, let's see what we got here. It's 2.5 comma negative 1. So I'm going to write that in. Because remember, our focus is always inside that parabola. The directrix is always going to be behind that parabola, right? It's going to be outside. And so again, let's kind of zoom into our graph here. Starting at my vertex, now I'm going to go 1.5 units back. It is a little bit off the graph, sorry about that. And we're going to draw this line right in. We got our directrix here. Well, that directrix is, let's see, 1, 2, 3, 4, 5.5, right? So that's going to be x equals 5.5. You won't see this very often. You might see decimals and fractions a little bit, but not too often for these types of examples. And so the last thing we're going to do here is we're actually going to draw the parabola in, right? And so I know that distance, that width, that focal width is going to be 4p. So in this one, our focal width is 6. Okay, so let's go ahead and try to draw this in. So the width at the focus is 6, which means I'm going to go 1, 2, 3 units one way at the focus. I'm going to go 3 units the other way, 1, 2, 3. And now I can kind of sketch that parabola. It doesn't have to be perfect, right? But I got that general shape. The important part is getting those important features. The vertex, focus, directrix, axis of symmetry, those are the important features. And the direction it opens, that's kind of the most important part here, right? I don't care if your drawing is perfect, I care that you're getting those important features there and you're really understanding that. So what we've seen so far is we saw a graph with our x squared, right? That was our first graph right here, the one that opens up or down. And then the second graph we saw was one where our y was squared, and that was opening left or right, depending on if it was positive or negative. Okay, so you're going to take some time to actually practice that in the choice activity. But right now, we're going to do 2 more examples, and we're going to actually write equations for parabolas now. All right, so what we have down here is kind of a list of kind of directions on how to write these equations. So I would really use these on your choice activity, making sure you're kind of getting this down so that you really have the general idea of how to write this equation. The first step is the most important step, and a lot of people try to just skip past this step. Make sure you're actually sketching the graph of the given information. And so let's look at our first number, number 3. It says if 1, -4 is the vertex and 5, -4 is the focus, we want to write an equation for the parabola. So again, our first step here is to actually draw a quick sketch of this. And this is what I mean by a quick sketch. Right, I have my coordinate plane here. 1, -4, okay, 2, 3, 4, somewhere down here. That's our vertex. That's that important vertex there. And then we have 5, -4 is the focus. So I'll do that in blue. So 5, 1, 2, 3, 4, 5, -4. That one's the focus. And this is why I draw this sketch in, right? This gives me the information on which direction this opens. Because I know my vertex is here, my focus has to be inside the parabola. So my graph is going to look something like this. It's a terrible drawing, but I know it opens up to the right, which is an important piece of information. It also gives me this distance here from the focus to the vertex. That's our p-value. So that's another piece of information I get just from the drawing. And that p-value there, well, from 1 to 5, I'm just kind of looking at those x values, our p-value is 4. So just by drawing a picture, that's our first step. That right there is giving me a ton of information about what this equation is going to look like. So please, please, please do not skip that step. You're probably going to get the question wrong if you skip that step. Please draw that quick sketch. If you ask me a question on the test or on an example, and I don't see a sketch there, I'm going to be like, all right, that's your first step. Draw that sketch out. All right. So let's move on to step 2 in just a second. Okay, so now that I have that information, I'm just going to move on to step 2. Like I said, it says to write out the shell of the equation, which I did. Identify if 4p is positive or negative. Well, it's going to be positive because we said it's opening to the right. So if it's opening to the right, we know it is going to be positive. Then it says, what is squared, the x or the y? Again, it's opening to the right, which means I know that the y is going to be squared. So I'm going to put a y there. I'm going to put an x there in the equation, and I'm going to move on to step 4. It says to find the vertex. Well, I already know the vertex, right? It gives me that vertex is 1, -4. Just be careful when it says to put that vertex in. I'm kind of doing the opposite of what I see here. So if my vertex is 1, -4, vertex right here. I'm going to do y plus 4, because that's my y coordinate of the vertex. And I'm going to do x minus 1, because that's my x value of the vertex. Just be very careful when you plug it in. I see a lot of silly mistakes here where people just flip the x and the y, right? The x coordinate of the vertex should go with the x. The y coordinate of the vertex should go with the y. Moving on, let's plug in our p value, right? We already found p actually when we drew it out. Let's plug it in. So I know p is 4. So I'm going to plug that in. So I have y plus 4 squared equals, I'm plugging that p value of 4. So 4 times 4 times x minus 1. Well, let's just do this right now. 4 times 4 is 16. So I'm just going to rewrite this as 16 here. And let's look at number 6. Write out your final equation. Double check if 4p is positive or negative. This looks correct to me, right? We don't have to simplify anything else. We got our 4p is positive, which is good. We got our vertex in there. We got y squared. That's all I have to do for that type of equation. All right, so let's move on to number 4. Number 4 gives me some different information. It's going to be a little bit harder, but again, my first step is always the same. I need you to pause the video right now, try that first step on your own, sketch the graph on your own. Pause the video. All right, so I just had to stop right there for my drawing because I want to make sure you get the vertex right for this one, and this is a challenging one for the vertex. So I don't give you the vertex in this example. That's what makes this one probably the hardest one you're going to see here. I have the directrix, I have the focus, we're going to need to define that vertex. So that's what I'm going to show you how to do right now. So I know our vertex is going to be right in between the directrix and the focus. And so it's going to be somewhere around here, right in between it. Okay, but I don't know exactly where it is yet. That's what I'm trying to figure out. It's going to be, again, right in between, which means the x value of the vertex should be -3. That shouldn't change. What I'm going to need to figure out is the y value of the vertex. So I'm going to use these two numbers here. I have -6 and 1. Okay, it's right in between those. Well, if I know it's right in between those, I'm just going to add those up and divide by 2, kind of like the midpoint formula if you remember that one, right? I'm just adding those two values up, dividing by 2. My vertex is going to be at -3, comma, -2.5. Once I add them up, divide by 2. So let's go ahead and draw that in. Again, it doesn't have to be perfect. We're just trying to quick sketch. I know it's opening downwards because, again, that focus should be inside that parabola. The directrix should be behind it. So right now I have the vertex. I know it's opening down, which is important. And now I can kind of draw out that shell of the equation. All right, so again, I know this one's hard. It's okay, we'll get through it together. So let's draw out our shell. Okay, so we got to figure out what is squared. Well, before I do that, I forgot step 2. Okay, I have my shell. We have to identify if 4p is positive or negative. Well, if it's opening down, I know that 4p has to be negative, right? Because again, it is opening down. Now, I'm going to figure out is x or y squared. Well, if it's opening up or down, I know x has to be squared, so I'm going to put an x in here. I'm going to put a y in right here. Let's move on to step 4. Find the vertex, which we already did, and we're going to plug it into the equation now. So with the x, I know my x coordinate of the vertex is -3. So I'm going to put x plus 3 squared. Remember, it's the opposite of what you see. I'm going to put y plus that 2.5. Put in that y coordinate of the vertex in. All right, let's move on to step 5. Now I need to find that p-value. So let's go ahead and look at our picture here. I want you to pause the video just for a second. I want you to try to figure out that p-value on your own just by looking at that picture right there. Remember, p is that distance right here between the vertex and the focus. Okay, so go ahead and try to figure out that p-value. All right, so hopefully you pause the video. That value of 4p, if I just, again, I can count on the graph or just subtract the two numbers. That value should be negative 3.5 because, again, it's opening down, so I know it has to be negative. So let's go ahead and plug that in right now. So I have x plus 3 squared equals 4. Plugging in that value of p, that negative 3.5, and then that y plus 2.5. Finishing it out, right? If I just multiply that 4 times that negative 3.5, let's go ahead and do that quickly. That's just going to be negative 14. I can write it. There we go. And so now I have my equation here. I just want to make sure I check my final answer. If 4p is positive or negative, it's negative because it's opening down. I have my x squared, which is good because, again, I know it's opening down. This is my final equation. So you got to be really careful with these. What information am I giving you? Okay, so that's why the first step is super important. Draw out a sketch, see what information you have, what information you still need, and kind of fill in the blanks. It's kind of like a puzzle. All right, so use these notes to help you out. Again, this is probably the hardest objective. Sorry, it took me 31 minutes to describe it. But please use these notes to help you out with the practice. Don't skip any steps. Don't try to rush through it. It is going to be difficult, but you can get through it as long as you're taking your time with it. All right. Good luck, and until next time.